Hi, welcome to clickmyproject.com. Here we are going to see the topic called Malware Clearance for secure commitment of OS level virtual machines. Let us see the abstract of this project. The virtual machine provides the software implementation process where the task created and closed. Basically, virtual machine has two types, that is process virtual machine and system virtual machine. It provides the environment for single program execution and system platform. The problem of virtual machine is there is a no malicious activity detection, only the engine updates sent to the VM host environment. In this paper, we propose the VM commitment system called CCOM for provide automatic elimination of state changes. State elimination proceeds in OS level information flow. The CCOM consists of three steps. They are grouping state, change into cluster, differentiate between Benign and malicious state, and commit the Benign cluster. Mainly, CCOM has three novel features. First one is the use of OS level information flow instead of huge log data. It detects the compromised OS object one by one and convert object into cluster, then identify malicious. It reduces the false positive rate when identifying malicious cluster. Let us see the data flow diagram of this project. First, we establish the connection between the virtual machine and the host. After the host gets connected, we capture the OS level information flow. Then identify the compromised OS object. After identifying it, we are grouping all objects into the clusters. Check the object for malicious data. If the malicious data is found, then it gets updated into the hash table. Else, the project is considered as a Benign object and it is checked for a Benign and malicious nodes. After it gets detected, the malicious node gets removed and the Benign update gets updated into the host machine. Let us see the running procedure of this project. Run home.java. Click this arrow button to navigate to the next page. Here we are starting the host environment. Click start button. Then minimize this two window. Run virtual machine environment. Click get host connection. If host is connected properly, then the host is available message will get displayed. Else it display the connection get refused. Click get detail. This is the detail about your entire system. Click next button to navigate. The entire OS flow get captured in this window. Click the capture the flow. These are all the entire OS flow. Click grouping to group the entire OS flow. After that, click correlate object button. It forms the flow into 6 clusters. Click next button. Click clusters. Here these are all the 6 cluster get listed. Select the cluster. Here I am selecting cluster 1. Click apply process. The suspicious status get updated here. After the entire status get completed, the pop-up will get displayed. Click OK. Click next button. Select. These are all the entire flow traced as a traced and labeling in suspicious object in cluster 1. Click recognize. If the malicious is detected, then suspicious status will change to detected. Click view suspicious. The suspicious cluster is cluster 1. Click labeling subject suspicious cluster. Select the cluster 1. Click dependency. The entire network process dependency and executable files are listed here. Click attach table. The label will successfully attached by clicking this button. Then click next button to navigate. Click label list. This is the list which contain the malicious data. Click table 1. This is the hash table which consists of only the type A, and this consists of type B, this consists of type C. The overall table is the combination of all A, B, C types. Click commit to commit the malicious behavior. Click label list. Cluster 1 is a getter and it commit for malicious. If it is detected, all trace amount will get display here. Click remove the cluster to remove the entire cluster. Click next button. This is for benzene. The cluster 1 get removed and other 5 cluster get listed here. Click benzene OS flow. After removing the malicious data, remaining flow get listed here. This listed flow will updated in the host environment. For that, updating the behavior in host environment, I am updating as host.doc. We have to select the type here. Click graph button to see the graph. This is the graph which is based on FEM and the CCON, in which the y-axis represents the request per second and x-axis depends on number of concurrent lines. Thank you for watching.